Once somebody gets a possible set of answers, we'll put it up and just see, because that may spark some people to get other answers. So let me know if any of you have a set of answers that will work. We'll try them too. Who just joined us on their iPhone because it doesn't have a name? If you could just let me know so I can...
Lori Martin.
Oh, thank you, Lori. I'll just call you iPhone. Is that okay?
Okay.
I'm joking. Yeah, I can mark you here now. Thank you.
Hey, Brian.
Yes.
Did we get our midterm marks back yet or no?
Where is it here? Hang on. No, but I think I'm just saying, I think I posted what it was. Let me look here. What was yesterday? Right there. Day 11. So for everybody there, I'll update marks for everybody on Friday, and then I'll give you everything. So I'll break your midterm and your overall mark down. I'll do that Friday morning.
Okay, thanks.
Maybe not in the morning. It depends on how much I get done. But like I said, I think I told everybody nobody failed at all. It was actually the marks were quite good, so I was quite impressed. Ooh. Where are we? Oh, we're doing this one. Sorry. Let me open that one back up. There we go. That's what we're doing.
I think I found 3 if I did it right.
Well, can we start with one set first instead of all 3?
Like, do you mean a set as 2 numbers?
Yeah, it's going to be 2 numbers. So here, read me the numbers and then we'll see if it works or not. We'll decide right away. Let's start with the far left one. This one here.
Oh. I might have done it wrong then.
Well, let's find out.
I just added numbers that were 2 digits. I did a 63.
A 6?
I put 2-digit numbers.
No. You only got to put 1. So if you wanted a 63, it would have to be like that, right?
Mm-hmm.
And you can either read that as 63 or 36. It doesn't matter because order doesn't. So, I mean, one of those, that one's divisible by 7. So 6 and a 3 there might work. Okay.
42 is 2. 4 and 2.
Okay. So let's say you did 63 and a 42, right? But you'd have to also check these numbers, right? You'd have to check the 23 or 32 and the 34 or 43, right? It has to match up.
Okay.
Keep trying. Anybody? Even if you don't think you don't have one, we can test it out and see if it's going to work or not. Let me give you a hint. Now, it's 7 and 3. It has to be divisible by 7 and 3. So what you could do to kind of get yourself rolling on this is think of multiples. right? 13 times 1. 13 times 2, right?
I
13
got it, but I think they're all divisible by 7.
Sorry, what?
I got it.
Okay, so
I
give me
think-
the numbers. Let's start with this one here.
Where? Where should I say? I put a 4 here.
A what? Sorry?
A 4.
A 4. Okay, go to the oops. Go to the middle one.
2.
2. Go to the right one, far right.
8.
8. Okay, let's go to the top
9.
and the bottom one.
And 7. But they're
Okay.
all divisible by 7.
Okay, well, let's take a look. So is this 42 or 24? Which one you want to use?
42.
And 42 is divisible by 7, correct. Okay, 28 or 82?
22. 28.
And 28 is divisible by 7, correct. 29 or 92?
Oh, so I forgot about that one.
Well, double check. 29, is that divisible by 7?
I'm not sure. I doubt it.
92
Yep.
maybe?
Both aren't. I forgot that link, but the others are all.
Okay, so you might have to change something then, okay? Over here, so let's get back over here. So you could just keep going these multiples up, and if you look, there's combinations of numbers there. And you could do 7, you could start with 7, right? And 14, and 21, and 28, ... right? This, though, maybe doing that first might help you to figure out what numbers to put in there, right? Come on, somebody must have one. Sorry, I see that now. You had a question there before, Heather. I'll answer that at the when we get a break or something. Just remind me again, you want question 20. Okay.
It's okay, I found it.
Oh, good. See, you know what? I'm glad I could ignore you and then you could get the answer. Oh, it's the best way to teach. Just ignore the students and they get it. All right. Any more takers on this one? Anybody think they have a possibility? Justin, was that a throw up your hands in frustration possibility or what? All right.
I always am left with one number that just goofs it up.
Okay.
We need a whole class, Brian.
No. Like you look at the, for instance, like the 13 here and the 39, right? So if you put a 3 in the center, you could put a 1 on one side and maybe a 9 on the other. Oh, if I got a 1 over here, maybe I can put a 2 up here, right? You got to look at patterns. And if you do the multiples down the side here, right? Just do them all until, remember, 2-digit numbers. So technically this 7, we don't even need this first 7 because it's not a 2-digit number, right? So it's going to start at 14. And as soon as you get to a 3-digit number, you can stop and you can make your full list to do it that way, right? But I'll leave that for you guys to work on. I'm not going to give you the answer. Like there's 5, well, minimum 5. Okay. It's Thursday. We are technically, this is the halfway point. We've had 11 classes and the next 3 weeks is 11 classes because holiday being Monday. So we are at right in the middle. You were half done the course. Do you feel like you've learned anything? Learned anything? Sorry, I couldn't say that with a straight face. Okay. I'm just joking with you guys. Okay, so let's do, what are we doing? Let's get out of here. Let's get back into the fun stuff. So we are doing day 12 today. Remember, if you're unsure of what we're doing or what you need, you should be looking at that. You should be looking at the website every day. It's useful. So for instance, I put on here, hey, day 12. Hey, please print off Cupid's arrow puzzle and the 4-quadrant puzzle, graphing puzzle, if you can. Right? You should be,
Algebra.
okay, we'll get that. All right. So contemporary math. Here we go. We are on day 12. So we did Cupid's arrow. Now we're going to do chapter 8. And chapter 8 is algebraic reasoning and an introduction to graphing. So I'm talking about like coordinate systems because I got a little puzzle for you later. Are we being marked for the, well, no, it's not in the course outline, Sam. This is just extra stuff. The only thing you're being marked on is the assignments, the tests, the midterm, the final, and the activity that's at the end. That's all you're being marked on. Okay, what are we on? Day 12. So chapter 8. Let's pop this up here. I already have it here. Let's do slideshow from the beginning. Okay, perfect. So you can see what we're covering today. There's only 3 little parts to 8, 8.1, 8.2, and 8.3 there. Algebraic expressions, graphing points, which is really important. That's the Cartesian plane, like X and Y coordinates. And there's connection between algebra and geometry, as in distance between 2 points, introduction to slope, and well, you'll see as we come up here. Okay, let's rock and roll here. So when we're talking about algebra, algebra just describes generality. So for instance, specific stuff, 5 + 8 = 8 + 5. This is algebra, right? It's the whole process of taking numbers, and then we're going to add letters in a minute, right? Adding, having numbers and making them work however way you want. And this is a basic one because this is just addition. But you know, with algebra, we can have addition, subtraction, multiplication, division, a whole bunch of stuff. So that specific general would be something when you have letters, because what we don't know, right? The variables in this case, we don't know what they are. They could be anything, right? M and N could be a whole endless possibilities here. Okay, this is all background information on what algebra actually is. So why do we use algebra? I use it to make students cry. That's the only reason I use it. It's kind of fun. I'm joking.
To figure out variables.
Well, okay, we can introduce variables, but I mean, you can have algebra with specific stuff too, but the whole purpose is to solve a problem that you don't know the answer to, right? So for instance, algebra solves problems and explains patterns, right? So like you were just saying, Alice, you could use a variable to represent something, right? So that you could use a variable A to represent apples. You can use B to represent bananas. It really makes no difference, right? Then what you do is you set up an equation which shows the relationship, right? And then you solve it. That's the whole basis of algebra. And you're going to find when you teach this to students, to kids, they're going to freak out. They do not like algebra. It's one of the things that really scares them. Right after fractions, by the way. Fractions are going to be the big one, and then you're going to see algebra. I could walk into a room full of adults and give them an algebra problem, and many of them would freak out. It's super common. Algebra scares a lot of people. But one of the main things too is you can also then apply algebra to Cartesian plane. Now, when I say Cartesian plane, it's just the fancy word for X and Y axis, right? You know the old X, right? Excellent, Y, right? I don't know if you've ever heard that, right? Okay, so what we can do that, and then we can go on to graph, oops, sorry, we're on the wrong, graph them in Cartesian plane, which can solve algebraic problems. Now, you might have remember that from high school, right? You have a linear, you have a line. Everything on that line is a solution to the equation, right? All the X and Y's. We'll talk about that later on when we get to the graphing part. Okay, now, variables, kind of the main thing of algebra after you get with the numbers, right? Variables can be used to describe a general property or pattern, right? We use variables all the time. You think about it this way. If you're playing basketball and you want to get onto the court, you have to substitute yourself in to the court and somebody else has to be out of the court, right? Well, it's the same with algebra, right? You have a variable and you're going to substitute a number in for that variable, and then the variable's gone and you have a number to replace it. And hopefully the number you've picked makes the pattern equal to each other, right? So there's a pattern there, right? Because sometimes when you're solving algebra, you can get the wrong answer. But one way to test it is to put it back into the original algebra equation and see if it works, okay? Algebra has its built-in test mechanism to see if it actually works or not, okay? Okay, so what do we do here? Oh, so generalized variables. So, oops, you know this pattern right away. Remember the old distributive pattern, right? And this applies with variables, this applies with numbers. This is a multiplication over addition. Remember, we could do this with subtraction also, doesn't matter. But the distributive property is if anything's on the outside there, right? A, for instance, A, you go A times B and you go A times C. And you can see it written right here. You're going to see a lot of that when you actually start doing algebraic problems. You're going to see a lot of stuff like with addition, subtraction, multiplication, like the distributive property. All those properties we talked about are going to be in play when you do algebra. Okay, so when you do algebra, you can describe it in different ways to get the same results. So for instance, Jolie was born on her 3-year-old sister Kendra's birthday. Okay, so we got Jolie, we got Kendra. Which one's older? It's not a trick question. Which one's older?
Is it Kendra?
Jolie.
Yeah, it's Kendra,
Jolie.
right? No. Kendra was born on her 3-year-old sister Kendra's birthday. So Kendra was 3 when Jolie was born. Okay. So what you can do now watch here. So let's set it up. So let J represent Jolie's age, K represent Kendra's age. And what it is you can represent this whole pattern here 3 ways, right? Jolie's age is Kendra's age minus 3. Right? And you can use this in the future. So for instance, if Kendra is 10, we know right away Jolie's at 7, right? We can use that. You could also describe it this way. You could say, hey, Kendra minus Jolie, the age of Kendra minus the age of Jolie is 3, right? 10 minus 7 is 3. Well, that works also. And one last way, Kendra's age is Jolie's age plus 3. So for instance, if we knew Jolie was 7, it goes, yeah, 7 plus 3. Oh, Kendra must be 10 then, right? Like, I don't know if you've ever thought about it. I mean, those are really simple examples of just Jolie and Kendra age-wise, but you can represent it a whole stack of different ways. Okay? Now, when you're teaching algebra, you're going to teach it in stages, depending upon the age group you're in, right? So for instance, at elementary school, you might do something like this, right? And you could do this with manipulatives. You could do this numerically, like with the numbers right here. But you leave like a block there, 7 plus something equals 10. So some of the kids might go, okay, sorry, I meant 3, not 7. 3 plus something equals 10. So some of the kids will start counting. Okay, I got 3, 4, 5, and they start counting right on their fingers. Some of the kids will go backwards. They'll go, okay, 10 minus 3 gives us our 7. But this is algebra because you're solving for an unknown. Okay. And then once we get up to middle years, and when I say middle years, I'm talking grade 8 into high school, you can start doing this type of algebra where you have unknowns, right? So in this case, right, something minus 3, well, you can solve it and figure out that x is 3. This one, something plus 4, well, x has to be negative 4, right? That's moving into 8 and 9 into high school. Okay. But again, there's unknowns, there's variables. This is all algebra. Now, kind of the most common use of algebra and variables, and you've seen this before, and in fact, on your formula sheet, there's a stack of these, is variables with formulas, right? Let me put some of these down here. So these are just a bunch of generic formulas, right? The distance formula is rate times time, right? Interest compounded annually. That's a slightly different interest formula, but it's still a formula. Perimeter of a rectangle, right? 2 times the length with 2 times the width. And if you look, there's variables all over the place in here. And these variables, these letters will represent numbers. Area of a circle, 2 pi r, right? So when you teach it at the early age, you're going to have that small stuff like without variables. Then you'll start to incorporate variables, and then you'll start using formulas. Okay. Okay, now there are 2 things here. First one is an algebraic expression, and then an algebraic equation. There's a big difference. The algebraic expression is just a bunch of variables, numbers, and operation symbols. So addition, subtraction, multiplication, division, all that stuff. That's just an expression. We use those all the time in math. To turn it into an equation, how do we do that? How do we turn an expression into an equation?
Add the equal sign.
That's it. That's the basic. Like if you look at these ones, those are all equations, right? Because there's something equal to it. D equals this. A equals this. P equals this, right? So the expression part would be like just the RT or the pi r squared. That's the expression. As soon as we put the equal sign there, we now have an equation. Okay. Okay, so here what we're going to do, I want you to form an equation based on this. Okay, let's see if we can do it. So what we got is we got an item at a store. Every item is increased by 15 cents. So what is the cost of an item that used to cost C dollars? Okay, so if you have something that used to cost $1, it now costs $1.15. Okay, so how do you write that in the form of an equation? And they give you the variables already. What's the main one? Or sorry, expression, not equation. Sorry.
C plus 15.
Yeah, C plus 15. Now you got to be careful with that because you either write with C plus 15 cents, right? Or you'd have to write C plus 0.15, right? Because it depends if it's in like if it's 0.15 or 0.15, that's dollars, right? That's how we write dollars for 15 cents. But if you did C plus just 15, you would have to add the cent symbol to it. Okay, and you can right here. So cost equals cost plus that, or the new cost minus that is the old cost, right? That D is the new cost. You can, like I said, you can write it numerous ways. Okay, let's try this one here. The electric power company charges $5 a month plus 7 cents per kilowatt hour of electricity used. Okay.
5m plus 7.
Say that again, one more time.
Would it be 5m plus 0.07?
Okay, so you said 5n because you're talking about n being the number of kilowatt hours, right?
Yep.
Okay, close, but here's the deal. It's a flat rate of $5. So no matter if you use 1 kilowatt hour or 1,000 kilowatt hours, you still get charged the $5. So the n doesn't go with the 5. Oh, sorry, go ahead.
I had said m as in month.
Okay, or month, whatever it is. Okay, so I see. So 5. 5. You're basing it on the number of months. Okay, I got you. Sorry. But no, we're just talking about straight cost here. The 5 is just by itself, no matter what. It's called a fixed cost. It doesn't change. Here's your variable cost. And you could use whatever letter you want. I think they use K. You could use N. You could use whatever you want, right? Because this is this is known as the variable cost because it changes depending on how many kilowatt hours you use. And again, since this, you got to be careful too. If this 5 is in dollars, you can't use a 7 there. You got to use the 0.07 because that has to be in dollars. Both of them have to be in dollars. If you wanted to switch to cents, this would have to be 500 plus 7K, right? If it was in cents. So you got to watch your units too. That's another thing. Well, you'll see as we go along. Okay. Okay. So we said an expression, we already know this, is with no equal sign. And we already defined what makes it an equation. Bang, we put in an equal sign. And the main thing you have to do is if you are testing this and you're getting students to solve this, you can get them to do the work and then they can take the answer and plug it back in. And if you look here, the left side of the equation has to equal the right side. And if they equal each other, you know you did the right answer. Okay. Now, when we're solving an equation, sometimes there's more than one answer, right? Now, in early years, there's only going to be one answer, right? When you're teaching algebra to those kids, there's only going to be one answer. But as you get into middle years and then into high school, you can have what's called a solution set. And a solution set is just however many answers there are that make the equation true, which makes the left side equal the right side. That's all it is. And if they're equivalent, then we have the same solution set. Okay, so for instance, these ones here, this is high school level, right? You can be able to solve equations by this, right? By multiplying the whole thing by x minus 2, right? This is kind of similar to what you guys were doing in the assignment when you had those fractions with the inequalities. Slight variation, you can multiply by whatever the denominator is. So what you're going to get is if you do that, you're going to actually get an equation that looks like this. X minus 2, x plus 1 equals 0. Now, here's the deal. When you have stuff like this, which is binomials, right? You can actually have more than one solution. So work with me here and let's see if we get this. Look at the first one here, this x minus 2, x minus 2. What number do we plug into there? Into the x minus 2, we're replacing the x, that'll get us a value of 0. What number? Into x minus 2 here. It's right here, by the way.
2.
2, right? So if we plug in 2, right? 2 minus 2 is 0. Perfect. We ended up with a 0. Okay. Now, here's the interesting thing. We also have to worry about this other binomial over here, right? What number do we plug into this one? This x plus 1. What number do we plug into that? Make that 0. Well, you see right away it's -1. Well, okay, that doesn't make any sense. You could have more than one answer. Well, look at this. For instance, let's say we actually just use 2. If we plug a 2 into the first part, 2 minus 2 is 0. If we plug a 2 into the second part, 2 plus 1 is 3. Okay, but does it still equal 0? Yes, because 0, this first part, times 3 is still 0, right? Left side equals right side, because we know anything multiplied by 0 is still 0. So this type of question here has more than one answer. It actually has a solution set, right? That's what we're talking about. Okay. Now, this is all leading up to graphing. You'll see in a minute. So the next two pieces we got to look at is domain and range. You guys, have you heard those? Have you heard that before? Okay. Domain and range. Here's how you remember. I'm going to give you a little hint, and this is what I tell everybody. A lot of people really have trouble with, okay, what is the domain? And the domain is, it's a function that has each element of, if you look right here, x. Right now, let me go to the next one. And the range is for y. Okay. So some people are going, well, how am I going to remember that? Domain, x, range, y. Well, here's the deal. If you know your alphabet, you already have the solution. Sorry, what was that? Lori?
Oh, sorry, no.
Oh.
I'm just switching from my iPad to I mean my iPhone to my computer.
No problem. Sorry, I thought you had a question.
I opened my computer and a fly flew out of it, like when it was closed.
So here's how you remember domain, range, X and Y. If you know your alphabet, start singing to yourself. Dun, 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 right? X comes before Y, D comes before R. Right? X comes before Y, D comes before R. So domain is X, range is Y. Okay. And we're going to get more into that as we start graphing stuff later on. You'll see that there's a domain and range component to this whole thing. Okay. So one of the main things is when we're talking about functions, right? This is a lot of functions. Anytime you have a set of values, right? An X and a Y and an X and a Y and an X and a Y, there's a relationship between the X and the Y. We have what's called a function. If you're like, I don't know what he's talking about. I've never seen a function before in my life. Well, yes, you have, because oops, functions, there it is. The area of a circle can be expressed as the function of a radius and pi. That's it. That is actual, that we know that as a formula, but it's a function, right? If we plug in a value of R, there's one of the parts. If we plug in a value of R, we could do the math, right? Multiply and squared and then multiply by pi. You're going to get a value over here. Oh, you get a value. If you plug in another value of R, do the math, you get another value over here. And you can keep doing that. And what happens is you just get a bunch of values, and that can show that you get a function. Okay, so one of the ways is you can express functions in the form of a formula, just like that. Hey, you could express functions in the form of a table. Athena is 62 inches tall. Bailey is 68 inches tall. Caroline is 70 inches tall, right? There's a relationship between the student and the height. That is a function. Okay, you can also visualize them as arrow diagrams. This arrow diagrams, this is one you'll use when you're teaching middle years. You'll have concepts over here. I think we actually did this quite a few chapters back. We had pictures of paper clips and coins and dice and stuff, and you had to associate it. Okay, here's the deal. U has the value of A with it. V has the value. Whoa, wait a sec. How can U and V have the same value? That doesn't make any sense. Anybody want to take a gander at that one? How that works? Okay. Let me give you an example, and this will hopefully make some sense. Okay, Justin, you are letter U. Alice, you are letter V. Okay. So Justin is U, Alice is V. Pretend these are marks in the course. Could I give you both an A? Does that work?
Yes.
And that works, right? So you can have two different from this column, have the same one over here. Now, Alice, let me use you as an example. Could I do this? Could I give you an A and a B in the course? Could I put an arrow straight across and then an arrow to the B? Could I do that? Could I give you 2 marks for your final mark?
Nope.
No, that doesn't work, right? So in that respect, that is not a function, right? You have to have this value of X, or this first one, this domain, has to have one value, right, or range right over here of Y, right? So you can think of these as people in the class, and people can get different marks. Who's the bottom one? Who got the F in the course? Very sad. No? Okay. Now, so that's one there. That was with arrow diagrams. Now you can also use, and you guys have seen this before, you can visualize function as a machine. What are you talking about? We've done this already, right? This was actually, I think, was it in the assignment? Hang on. No, it was on the midterm, wasn't it? Yeah, it was on the midterm. Remember where I gave you sorry, what?
Input or out.
Yeah. So it was on there where you input something, you throw something in the top, this one squares it, right? And you can work this backwards. You have an output and an input, right? You've seen that already before. Okay. By the way, these are all like, how many have we gone so far? 1, 2, 3, 4. This is 4 ways to display functions. Now, the next way I'm going to show you to display a function has an entire section of math dedicated to it. And that is functions as graphs, right? This is some of you might like this, some of you might not like this. This is a very visual way of doing stuff, right? And remember, we have our x-axis and our y-axis, right? And we have points along here. There's functions, right? If we have an x, we have a y, right? So if we look over here, let's try to find something. If I go to x to 1, I go up. It looks like y is 2, right? If I look at that. If I go up to 2 here, it looks like maybe 2 and 4, right? I have a series of points. I have a domain and I have a range, okay? This is the stuff we're going to talk about right now. This is the whole next piece, right? That was 8.1. The whole oh, sorry, I don't even have chat open. People are going back here. Let me just double check to see. Sorry, is record. Yeah, I'm recording. No, we're not going graphing calculators. You can do it manually. Even though, right there, what do I keep in front of me all the time? A graphing calculator. Okay, so here we go. Let's talk about, let's talk about 8.2. So we're going to talk about how to basic graph points, lines, and some basic formulas that go with graphing lines, as in distance, as in slope point, slope intercept. Yeah, we'll get to that. Okay. Now, Cartesian coordinate plane, fancy name, woo, fancy name. But you guys know this. This is your X, this is your Y. Do you guys remember what the center part is? Right in the center. Do you remember what that's called? Has a fancy name.
Intersection.
Nope. Starts with an O and ends with origin. Wait, that didn't work. Sorry. The origin. You guys ever heard that? The origin? 0, 0 is the center of this. And if you look, this is basically, all these are our number lines, right? If we start at the origin here and we go to the right on X, that's positive. If we start at 0 and go to the left, that's negative. If we go back here and go up on the Y, that's positive. And if we go to the origin and go down, that's negative, right? So for instance, let's look at point P on here. It's 5, 3, X, then Y. Just like when we were talking about domain and range. So if you look here, you count over 1, 2, 3, 4, 5, and then you go up 3, 1, 2, 3. There's our point P. There is our set of points, 5, 3. Okay. Let's look at R. We start at the origin and we go, and you always do X, then Y. The origin, 1, 2, 3, negative 3, and then we go up positive 5. 1, 2, 3, 4, 5. We can do point R. That's quadrant 1. This is quadrant 2. We can go to quadrant 3 here. Negative 4 means we go over 4, down 4. There's our point. Back to quadrant 4 here. We go to the origin, go over 7, down 3. That should be from any course. If you took core basic math, you should remember that. You should remember that from high school. That was pretty common. I think most people really liked graphing because it was very, very, very straightforward. Okay, now you can use that. And if you have, let's say, points on a graph here. So let's say we have point P, right? Point P, we have our X and our Y. And you can see they're X1 and Y1 because that's the first point we're talking about. And we have point Q, X2, Y2. We can actually find the distance of this blue line here. And it's called the distance formula. Okay. Now you're like, oh, I can't figure that out. Well, yeah, you can, because guess what? I give you the distance formula. So the distance between P and Q is actually very simple. You take your X coordinate, the second one, subtract your first one and square it. And then to that you add the difference between Y2 and Y1 and square it. And then to do the overall thing, you take the square root of it. That formula looks really familiar. Does anybody see can anybody recognize the kind of origin of that formula?
I remember it a bit when I was doing graphing at some point. in my, I think it was my first year. I can't remember now, but it looks sort of familiar.
Okay, but what does it look like that we use all the time? Here, look back at this picture here, and I watch my mouse arrow here. Watch it. Watch what I do.
Sort
Is
of
that-
like Pythagorean theorem.
Making a triangle.
Oh yeah, hang on. Making a triangle. Who said Pythagorean? Who was that?
Me.
Eric, thank you. Sometimes I can't catch who said it really quick. Yes, you're right. That is actually Pythagorean theorem, right? Remember the old a squared plus b squared equals c squared. That formula is actually where this distance formula looks like. So look at this. This is actually, pretend like this is the a squared here, and this is the b squared. And then we add them together. And then remember, if you've always remembered Pythagorean theorem, the last thing you do is take the square root of it. It's actually Pythagorean theorem. Now, some of you might also notice this as, we can then talk about what's something called slope, which is coming up. And you might remember slope as rise over run, right? That's coming up. Okay, so let's do an example here. Well, let's keep going the example here. So the points on this one are 2, 5, 7, 8. Okay, so we're going to take the x values. You can see there, x2 minus x1, so 7 minus 2. y2 minus y1, so 8 minus 5, right? So 7 minus 2, right, is 5. 5 squared is 25. 8 minus 5 is 3. 3 squared is 9. 25 and 9 is 34. And then remember, we take the square root of it. So this distance, this blue line here, is approximately 5.8. For anybody that took pre-cal in high school, you probably remembered, you probably wouldn't have changed it to 5.8. You would have left it as root of 34. You leave it in radical form. I'm not worried about that. Okay, now, if you know those points, you can apply them to another formula called the slope formula. Now, the slope of the line is really quite simple. Here's the formula. And again, you don't have to memorize this. You're given it. You just got to be able to do it. So this one is very simple. It's y2 minus y1 over x2 minus x1. Okay, so the difference in y, or the rise, and the difference in x, or the run. Okay, so here it is here. Here's the same points again. Right, 2, 5, 7, 8. And we're going to find the slope of this line, how much it rises over how much it runs. Okay, so we can do the math here. So 8 minus 5 is your rise, right? 7 minus 2 is your run. And then we go rise over run. So 8 minus 5 over 7 minus 2, right, is going to give us a rise of 3 over 5. Now, watch how that actually works. If you start at this point here, 2, 5, you actually go up 3, watch, 1, 2, 3, and then you run, or you go X, Y, you go 8 times. Or sorry, 5 times, not 8. I wish I could count. It would be helpful if a math teacher could count, right? And you go over 5, and this is where you end up. So this is the slope, okay? And what we're going to find, you're going to find is you have positive slopes and you have negative slopes. So for instance, have you ever been tobogganing? Or have you ever fallen down a hill? Let me ask, have you ever fallen down a hill? You know what slope is automatically. Oh, Justin, yeah, thanks, Justin. Right, you know what slope is, because slope is the rise over run, right? If you fall down the hill and then you're at the bottom of the hill and turn around and look up, that slope hasn't changed. It's just a difference in direction, right? One is positive, one's negative. Okay, that's all slope is. And again, you don't have to memorize the formula. You get it, right? You just have to know how to use it. Okay, so now when you're writing stuff out, so for instance, this blue line, we can write it in the form of an equation, right? And there's 2 types of equations that you will have seen. These are the 2 main ones. One is called slope point form. Okay, and what it is, you can see, is y minus y2 minus m times x minus x2. We use it, but it's not as common as the next one. Here it comes. The next one is the most common. Slope intercept form. Y equals mx plus b. You probably remember your teacher saying that at one time in your life. Y equals mx plus b. And you were like, don't tell me that, and ran off screaming into the someplace. It's really not that hard. All it is it tells you a couple things. M, and if you look back here, M is the letter we usually use to represent the slope. Don't ask me why. I don't know why they used M. Who knows? It's probably Latin or something like that. Who cares? I'm not worried. But that's your slope there. Okay, there's your slope. Now this B is the Y-intercept. And what I'm talking about for Y-intercept is where it crosses the Y-axis. Okay. You'll do a bit of these, I think, in the work coming up. Basically finding the slope and stuff like that. Okay, so so what you can do is, and you might have gotten to this at one time, is you can use, you have 2 points. You got P and Q, right? Like P and Q like this. There's P and Q. You can find out a number of things. You can find out the slope of this line. Yeah, you could actually take this blue line and keep extending it down until it crosses the x-axis, right? Then you have your intercept. But there's lots of formulas to, there's lots of formulas to do with that. And the equation, there they are right there, right? That's that slope point form, and that's just the slope. I really don't know why that, I can take that slide out next year because we already talked about it. It's not a big deal. Okay, wow, we were almost done this lesson today. This is a quick lesson today. Now, connections between algebra and geometry. So now, remember we talked about at the beginning, we talked about algebra, right? All the unknowns. Then this 8.2 is the geometry. Now we're going to try to connect them together. Okay. Do you know the difference between parallel and perpendicular? Most people could probably do something like that, right? But you can
That's
also
exactly what I did.
Awesome. Because that's the way most people think about it, is parallel and perpendicular. Now, but here's the deal, and this is it's sometimes really hard. You know what they are, but how do you explain it in words? Or better yet, how are you going to teach that to kids? Parallel lines. Good example is railway tracks, right? If you have a set of railway tracks, you have parallel lines, because if they're not parallel, the train falls off the tracks. So a lot of people can get that visual one, but mathematically what you say is lines are parallel if they have the same slope. Okay, does that make sense? So you have a line and you have a line. If they have the same slope, guess what? They're parallel. If you have the slope of this line and this slope is this one, you know they're not parallel because they will cross at some point, right? So mathematically, definition of parallel lines is they have to be if they have same slope. Sorry, it's lost my brain there for a second. Okay. Oh, here it is. Sorry. It's on the next line. Two lines are parallel if and only if they have the same slope or both vertical lines. Who cares? But same slope. That's the main thing. If two lines are the same slope, they're parallel. Okay. Now, perpendicular, right? How do you define perpendicular?
They have to cross.
No, it doesn't have to cross. You can actually stop it at the point. But what I'm more concerned about is how they hit each other.
Right.
Sorry, somebody said, who was that? Sorry, was that Lacey? No,
I said a 90. It's a 90 degree.
90. And Eric, I think you said that too, right?
Yeah, I just said a right angle.
A right angle. Oh, perfect. Actually, both of you got it. So Lacey said 90 degrees and Eric said a right angle. Guess what? They're the same thing, right? We'll talk about, and you can actually, there's actually more of a mathematical definition of that. If you actually have the slope of this line and the slope of this line, to prove that they're parallel, get this, and it's not in here, but I'm going to say it. The slopes are negative reciprocals of each other. So for instance, if you have a slope of 2 and the other slope is negative 1/2, you know that those lines are perpendicular to each other because the slopes are negative reciprocals of each other, right? So take 2, make it negative and flip it. Yeah, they are. Okay. And you can even go one step further. If you took those two slopes and multiplied them together and you got -1 as your answer, they're perpendicular. There's a whole bunch of proofs on perpendicular lines, but the main thing is they 90 degrees or right angle. Okay. A lot of this is kind of terminology. You got to really understand what you're doing or know about it. Okay. What's an altitude? Oh, that's not an altitude. What's an altitude? Some of you might not remember this. Like, what are you talking about? I know some of you know what an attitude is. No. Okay. What's an altitude? Well, let me show you a picture. Go ahead. So you were going to say something. Somebody's saying something.
Does it have anything to do with the height?
Yes and no. Yeah, it has something kind of height-wise, but it's, if you look at what it is, it's a line, you can read this, that is perpendicular to the line containing the opposite side of the triangle. So let me go 2 slides forward and you'll see. So if you look here, right? If you look at this line here, so let's say we talk about BC, right? The altitude is, there's our right angle that comes off, remember, perpendicular comes off to the other side, right? Well, in this case, there's 3 altitudes, right? You can draw an altitude of this side going over, this side to go over, this side to go over. Now, here's the deal. If you notice, it's not always in the middle of that line. Sometimes it could be closer to one edge, closer to the other, right? It's not, you can't use that as a definition, right? So when we're talking about altitudes, it's anything that is perpendicular to the opposite side. This is just for definition. I'm not going to make you calculate this. Now I could, hey, I could make you calculate the slope. That's understandable. I could make you calculate the slope. Okay. So that's what, so what did we do there? We did parallel, remember? Parallel, the slopes are the same. Perpendicular, they intersect at 90 or a right angle, sorry. Altitude, any line that's perpendicular from the opposite side, right? So the altitude of BC here is this AE, right? There's our altitude because it's coming from A to the opposite side, right? You can see all the, there's 3 altitudes there. Okay. Okay, wow, we're gonna have so much, we're gonna have so much time for the activities today, and they are fun activities. Now, what I want you to do, there are some questions to do. If you get a chance and you have a printer and you haven't done it, hang on, just let me show you one thing here. If you haven't done it, please, if you have access to a printer, if not, you're kind of hooped here. Go print off this 4-quadrant graphing puzzle, this one right here. This 4-quadrant graphing puzzle. If you have a printer, if not, you might have to just draw a, get some graph paper if you have it. That will work also. This, I've done this exercise every year for like 10 years or whatever, and it is hilarious because you always end up with some interesting results, okay? So in the meantime, let's start working on 8182. We got lots of time. Let's take almost 25, you want 25 minutes? Yeah. Maybe even more. And then that'll give us like a 15-minute break, and then that'll give us lots of time for the activities. And we may even be done early today. Because we're going into a long weekend. I know, Justin, nice. We're going into a long weekend, so that might be helpful too.
Ryan, I'm gonna go get my printer. I have access to a printer, but it's in another part of the house, so I might get kicked out because my wire into the computer is not very good. So
no problem. We're not going anywhere. We'll still be here when you get back.
okay, I'll be back right away.
Yeah, no problem. Now I think, hang on. No, Heather, I answered your question, didn't I? Yeah, question 20. Yeah, that's right. Olivia, yeah, you have till like 8 o'clock or so, or even just after that's fine. Olivia asked me a question. I'm just going back and trying to answer everybody's questions. Wow, there's a lot of people asking if I'm single. What's going on with that? I'm joking. I'm just humor. What else? Oh, Heather, you're still having trouble with that? Okay, no problem. You can hear me, right, Heather?
I can hear you.
Okay, so question 20. Let's go look at. Oh, yeah. You know what? This one is doing everybody in. Here, let me Do you guys have that 8-1? Well, you guys can go to the website to see the actual pages there. I'm going to switch to the smartboard just so I can do this question for Heather. Some of you might want to pay attention to if you haven't done 20 yet. Okay. See what this does, Heather, it takes you back, and if you, it really depends if you remember what you used to do with fractions. Let me give you an example, and then we're going to use that example to kind of help us with this next one, okay? So let me put down, whoa, that is way too thick. 1/2 x plus 3/4 equals 5/6. Okay. So this is similar to what you've done. Actually, we can even do this. We can even put this, whoa, that's not what I wanted. We can put this in its place. Who cares? It doesn't matter what symbol we put in. Now, one of the keys to this, Heather, is getting rid of the fractions. There's got to be a way to get rid of the fractions. So what I'm going to show you is there's a real nice little trick to this to get rid of the fractions. Okay. What we want to do is we want to take every term, every piece of that, and multiply it by something. Okay. So Heather, what do you think we could multiply this by to get rid of the fractions? Take a guess. It's not right or wrong. I'll explain it.
I don't even know. Are you trying to get like the bottom number the same?
Correct. I'm trying to get yeah, that's one way to look at it. I'm trying to get the bottom numbers the same, or basically I'm trying to get rid of the bottom numbers or the denominators. Just say something and we'll see if it works. What'll happen is if you get it wrong, as soon as I show you, then that'll get you your next answer in the ballpark. So give me a number.
5.
Okay, so let's say you pick 5. Now watch what happens. If I go 5 up here, 5 times 1 is 5, divided by 2 is still 5/2. Crap, that didn't get rid of my fraction. So let's try a different number.
So would you go 2?
Okay, so let's try 2. So if we try 2, right, 2 times 1 is 2, and then divided by 2 is, oh, awesome, we got rid of the fraction. Excellent. Now, but here's the thing though. If you multiply that first term by 2, you have to multiply everything by 2. That's the rule of math. Now watch what happens here though. 2 times 3 is 6, divided by 4, oh, is 6/4, which is 3/2. So that didn't work in that one because that still gives us a fraction. Oh, crap. That didn't work.
Mm-hmm.
Okay. So let's go back and let's think about this number up the top here. 2 worked for the first one, but it didn't work. It won't work for the second 2. So let's pick a different number. As in larger.
12 maybe?
15?
Okay,
Oh, no,
15. If we tried 15, it won't work because it will still end up with fractions. But who said, somebody said 12. Who was that? Was that Heather?
Me, Holly.
Oh, Holly. Thanks, Holly. Now, Holly, why did you pick 12?
Because all the bottom numbers are divisible by it.
Oh, there we go. Right. So if, for instance, if I gave you fractions and asked you to add those fractions, you would find a common denominator, wouldn't you? So in that case, you would try 12. So let's see if 12 works for everything. Okay. Okay, now let's do the math. 12 times 1 is 12, divided by 2 is 6. Hey. So far, so good. 12 times 3 is 36, divided by 4 is 9. Oh, put our symbol here. 12 times 5 is 60, divided by 6 is 10. Look at that. Now, can you do that math? That's one line algebra. You should be able to do that, right? Move the 9 over to the other side and then divide by 6. The big part about that was getting rid of the fractions. Okay, do you see that, Heather?
Yeah, that makes more sense now.
Okay, now let's look at this one here. Okay. So what we want to do is we want to do the same procedure. We want to multiply everything by something that's going to get rid of the denominator. Okay. So what do you think, Heather? What do you want to try?
$56?
Why'd you pick 50? You're right. Why'd you pick 56?
Because well, I mean, I got that earlier, but I just couldn't figure out the other part. So I knew like 8
Okay.
times 7 gives you 56, and then
Yeah.
7 times yeah.
Yeah, they're both, all of them works into there, right? So then you do the math. Okay, so you have to do the calculator for me. 56 times 7, hit equals, and then divide by 8.
49.
Okay, so 49x. Same thing here. 56 times 9 divided by 8.
63.
Okay. And then, oh, this is a big one. 56 times 47 divided by 8.
Divided by 7
Sorry, divided by 7. Yeah.
is 376.
Okay. Now, there it is. There's our basic line. Now you can start doing stuff. Get rid of the 63 by subtracting, and then divide by 49. You're going to end up with a fraction as an answer, but leave it as a fraction. That's fine. Does that make a bit more sense?
Yeah, that does.
It's when I teach fractions to when I teach algebra and I teach fractions to my grade 9s, my grade 10s, my 11s and 12s, I always show them that method because a lot of students really don't like working with fractions. So if you can remove the fraction from the whole equation, it's much easier to do.
Okay. Yeah, that made a lot more sense to me now. Thank you.
You are welcome. And let me put that back up there. From current slide. Okay, you guys keep working there. I gotta go keep drinking too much water. I'll be right back. I gotta use the washroom.
Brian.
Alice.
I need help with question 6 and 13.
6?
And 13.
Hang on, let's look at 6 first. Oh, wait. On the assignment or on the
Yeah, on the textbook. Page
text?
389.
Okay, thank you. 289.
389.
389. Question 6.
The first two look easy. I wonder if I have them right. The answer key doesn't offer an answer.
Okay, so Penny is P years old. Form an algebraic expression with the Penny's age in 5 years.
P plus 5.
Yeah, that works. Penny's age 8 years ago.
P take away 18.
Yeah, P take away 8, yeah. The current age of Penny's little brother, who will be half of Penny's age in 2 more years. So Penny's age?
P divided by 2.
No, you gotta do the other one first. You gotta go P plus 2 and then divide by 2.
Okay.
Because he's gonna be half her age in 2 more years. That make sense now?
Yes, it does.
Okay.
For P and
It's all about the wording, right? You got to be really careful with the wording on it. That was 6. What was the other one you said? 13?
Oh, there's a D. Is 6D
Hang on. Current age of Penny's mother, who was 4 times Penny's age 3 years ago. So
P take away 3
times,
so
you got it, times 4. You got it. And you would probably do the 4. You could do the 4 like outside the brackets if you wanted to.
Okay. And I'm stuck with 13. I possibly missed something at the lecture.
Here's the deal. And this is, remember the example I did with you and Justin? Could I give you both the same grade?
No.
Yes. I can give you both the same grade, but I can't give you 2 grades. Okay, so let's look at 13. So A is assigned to P, B is assigned to R, but look at C, pretend you're C. All of a sudden they have a Q and an S as a grade. Is that possible? No, so that one's not a function, right? But look at part B, right? A and B are both assigned to P, so that would be like you and Justin both getting P as a mark, right? That one works, that's a function, right? If you have an X value, it can only be assigned one Y value. That's it, that's the definition.
So that's the definition of a function. You can only have one Y value.
And you might have remembered, let's see if you remember this from school. I'm going to draw something here. I'm going to draw 2 things. So the first one, right, just linear. Can you see that?
I see a slope.
Right, if you do something called the vertical line test, I don't know if you remember that. See, it crosses just at one point. Yeah, do you remember that?
Yes.
That's a function.
Okay.
But watch, I'm going to draw something else here. I'm going to draw a sideways parabola, right? And if I do a vertical line test here, if you look, it crosses at 2 points. That's not a function, right?
Okay.
That's what we're talking about here. It can only be assigned one value. So for instance, that X value on the bottom is technically assigned 2 Y values. It can't be, that doesn't work. I can't give you 2 grades.
Okay.
Did you remember that from math?
Too long ago.
I'm just wondering, you might have, so.
Thanks.
You're welcome.
Brian, if we're ever stuck after hours and we want to screenshot your questions, can we?
You can, I might not answer it, so. Well, I might not answer it till the next day, right? And I usually don't answer stuff on the weekends, but you can try. If I'm near my computer, I will.
What about weekdays? I guess not.
Well, during the day, you can, like, I mean, I teach during the day, right? So, I mean, you can screenshot it and send it to me during the day. I might not get back to you right away, but I'll get back to you sometime during that day.
Okay. I also need help with 20. Page 390.
Question 20,
Yes.
the one about the Carolee made the trip to the store one afternoon, that one?
Mm-hmm.
What do we got here? So hours are on the bottom, miles from home is up and down. Okay. So what time did she leave home? That'll be
I
the
don't
first.
know.
Sorry, say that again. Oh, no, your mic's off, sorry.
I can't figure out the time.
Okay, so the bottom is hours past noon. So noon is 12
Oh.
o'clock, right? So it looks like 45 minutes or 3/4 of an hour past noon is when she left the house, right?
12:45.
Yeah, 12:45. Correct. And how long did it take her to walk to the store?
5 minutes.
Approximately. About 15 minutes. And how far away is the store?
5 miles.
Right, correct. So then, I mean, you figured that out, right? She walked to the store and then she walked home again, right? Another 5 miles back home.
Mm-hmm. But what does this line mean? The
Oh,
straight line.
sorry. That's not the store. She was walking to the store and then she realized she forgot her checkbook. Like she forgot her money basically. So then she had to go back home and then walk to the store. How far away is the actual store?
10 miles.
Yeah, it's 10 miles away, right? So she walked 5, then had to walk 5 back because she forgot her money, then walked to the store. How long was she at the store for, approximately?
An hour and a half.
Yeah, 1 hour. Yeah, pretty. Well, I don't know if it's an hour and a half. It might be close to just an hour. But anyways, yeah, you get the idea. And then it took her half an hour to walk home, right?
Okay. I looked at it the wrong way.
Yeah, that's fine. What we got here. Okay, I will be back in 1 sec. Some people printed off, or sorry, sent me some assignments.
Sorry, Brian, I just wanted to follow up on what you said to Alice there.
Yep.
So for that question, I got the answer, like A would be 12 plus 0.75. Would that be correct?
Hang on. Well, 75% of an hour, so 45 minutes. So she left home at 12:45.
Sure. So you would do it as like plus 0.45, or how would you write that then?
Well, it's like where she starts on the blue line is somewhere between 0.5 and 1 hour. So 0.5 of an hour is 30 minutes, right? So she left 45 minutes after 12 o'clock.
But so you would do it as 45 instead of as a whole? Like I was considering like 1 hour to be one whole. So I wrote like 12, considering 12 as the zero
Yep.
plus 0.75 of an hour. Would that be correct?
Yeah, but you could write, as long as you said 0.75 of an hour, because that's 45 minutes, right? You'd have to be very specific, because if you put 0.75, you'd probably think, oh, that's 75 minutes. No, it's only 45 minutes, right?
Gotcha. Okay, thank you. I was just wondering about
No
that.
problem. Oh yeah, I need to double check on attendance because some people joined us. Who am I missing from my list here? Oh, Nicole Friesen, but she emailed me already. Kayla George. Do we have Kayla on? Kayla George. No. Kayla George. Kyle, there's Kyle McIver. Good. Mark you here. Sorry, I missed you before. Farah, is Farah on? Farah. There's Farah. Perfect. There she is. All right. Awesome. Her. Who's the other one I'm missing? Christina. Christina.
I have a question.
Hang on, just give me 1 sec here. Christina is not. No, I don't see her. And so I'm just double checking attendance here. I just going to double make sure I don't screw anything up here. Tyson, I think I'm missing her. Is Tyson on? Tyson. No, I don't see Tyson. Oh yeah. Go ahead, Alice.
On page 406, question 5.
Hang on a sec. 406, question 5. Compute the distance between the pairs of points. Okay, yep, go ahead.
Do I do a Pythagorean theorem?
Well, no, you can use the distance formula, right?
How? Or like,
This one here. Where's the distance formula? Not slope. This one right there. That one right there.
oh, this is like the Pythagorean theorem.
It is. I mean,
But
because
it's not called that like this.
sorry, say that again.
Is it called the distance formula instead of the Pythagorean theorem? I don't know how to say it as a word.
Pythagorean. Yeah, you're right. They're similar, right? But use a specific distance formula on this one, right? So which one are we doing again? We're doing 6? Is that, no, which one did you say?
5a.
5a. Okay, so you have -2 here. Let me write it down here. -2, 5 is one of them, and 4, 13. So this is going to be your x1, y1, x2, y2. I'm just going to write it and then I'll hold it up. Oh, here, I'll hold it up there. So there's the 2 points there, right? And all I did was label them x1, y1, x2, y2, and then just use the formula that's on the screen right now that I have up for you guys to look at.
Okay, thank you.
You're welcome. So keep working if you want, but some of you can take a break. We're gonna get rolling back probably about 1:45. We'll get rolling back, and I got a couple activities. And if we finish the activities early, some of you can keep working on stuff, or you'll be able to log off after that if you want. But let's go for break time. Make sure you, if you need to stretch your legs, get a drink of water, go to the bathroom, get some food from the fridge, whatever you got to do. And we'll start back up at 1:45. And if you don't need a break, just keep working on the questions like you're doing. I got to send some emails back here. Hang on 1 sec here.
Just sent assignment 3 for you. I accidentally put assignment 2 in the email, but it's assignment 3.
Okie dokie. I'm sending back when it, oh yeah, there it is right there. Oh, well, I'm not gonna mark that. It says assignment 2. I'm not even gonna open it. I don't know what you're talking about.
Sorry, man.
I'm just joking with you. Yeah, I send back if once I print them off, then I send back whether I've received them or not. So you have record of that. So if you don't hear back from me, you probably didn't send it, or it didn't get to me.
Yeah.
Okay, let me print, actually, I'll print these 2 off, then I can send back. There's that one there. This one here, print. Print. And I'll be back in 1 second again. I'm gonna go pick up these print offs.
Brian,
Yes.
can you do 25 or on assignment 3?
Oh, thank you.
I'm kind of wondering about it.
25. Okay. The key to this one is you got to get X by itself, right?
Yeah, so would you like move 14? Would you move 14 over 19?
Careful. You're not just moving the 14 over 19. It's negative. So how do you get rid
Yeah,
of
the negative 2a. I forgot about that.
So how do you get rid of the negative then? How do you get rid of the whole negative 14 over 19?
Just change it to a positive.
So you add it to both sides, right? So you add there and then you add to the other side.
Okay.
And then it's just fractions. You're just adding two fractions, right? So the denominators have to be the same, which they already are. So then you just deal with the numerators.
Oh, I see. Okay. So you would just, oh, okay, I get.
So it'll be negative 7 over 19 plus 14 over
Plus
19.
14.
Over 19. And then just simplify that, right? You just got to do the two fractions together.
Oh, okay. Thanks.
You're welcome. I'll be right back again. I just got to get something from the printer and then we can start with some of the activities, I think. Well, let's get back to. So,
Can I quickly ask a question?
yeah, go ahead.
On page 406, question 13A.
13A. Okay.
I don't quite know how to draw them.
Well, there's two ways of doing it. You could either rearrange it so it's slope intercept form, or the more common way, the way you probably learned it would be this way. You basically create a table of values. So what you do is you create a table of values and you have X's and Y's. You just pick some random values of X. Let me see which ones work here. 0 is not going to work. Let's try -1. Is that going to work? Yeah, -1 will work. -2. What's that? 6. Hang on, I'm trying to do this in my head. No, that won't work. -3. No, -4. Well, that'll be 24. It's kind of a nasty one because of the 5. Whoa, where'd my screen go? Oh, there it is. Let me try -6. -6 will work. -6. You would normally, why is my screen not working here? -6. What about +6? 18, 6, no. What about 5? 4? 4 will work. Okay, so what it is I did some math in my head there. What you normally do with a table of values, you would just pick random values of X, right? Because what's going to happen is when you graph this, you need points on your graph, right? So if I pick -1, right, I'm going to take -1 as my X value and plug it into here, right? So if I plug it into there, I'm going to get 3 times -1 plus, what is it? 5y equals 12. 5y equals 12. And then you just do the math, right? You just do the algebra. So that's -3 plus 5y equals 12. Move the 3 to the other side. You end up with 5y equals 15. 5y equals 15. Divide both sides by 5. You end up with y equals 3, right? So all I did was take my X value of -1, plug it in, I get a Y value of 3. And you do that at least 3 times, because then what happens is you can do your, right, you can do your marks on here and you can then put in the points. So -1, 3. So there's my first point. Okay.
Why -1, 3?
Well, -1 is just a random number that I picked, right?
Oh,
And then what happens here is when I plug -1 into the formula, I get my y equal to 3. So I get my coordinate points, right? I get my -1, 3, right? Those are my X and Y values.
mhm.
Okay. That was a little bit trickier because you can't, like normally when you pick numbers, you pick nice ones like 1, 0, -1. This one happens to, you have to pick something a little more difficult to do it. But you might get up to some fractions, but big deal. So I think -6 and 4, I think those will work nicely for you if you try them. So.
Okay, thanks. I'll try.
You're welcome. Okay, so let's get back to this. So what I want you to do, either you have printed this off or grab a piece of paper, a blank piece of paper, and you're going to write on there addition, subtraction, multiplication, division, equals, and parentheses. So just write that on there. Because what I'm going to do is I'm going to give you some words and you're going to put them in the right categories. I'll give you about 10 more seconds or so just to write those words down. Unless you printed it off already, it doesn't matter. So one of the things that makes learning really hard, and especially for kids who don't have English as a first language, is they don't understand all the different words we use. And there is a lot of words we use in math to mean the same thing. So for instance, if I said the word plus, right? P-L-U-S, plus, where would you put that? Under addition, subtraction, multiplication, division, equals, or parentheses? You would put plus
Addition.
under where?
Addition.
Addition, right? Okay. So that's a pretty common word because we use that all the time, like 3 plus 5. Okay. So I'm just gonna chuck out a bunch of words, and you're gonna put them in the right categories. Don't worry about spelling because I'm not marking you on. I'm not marking you at all, but I'm not marking you on spelling. So let's do the next one. Subtract. Put that one on there. Subtract. Terrence, you're funny. It's like that Bare Naked Lady songs when he makes them say that in the song. So that was last one was subtract. Let's try times. Times. Divided by. Divided by. Here's a tough one. Is. I-S. Is. And if you're having trouble finding out where things think or where they go, put it this way. I could say 3 plus 4 is 7, right? So that should give you an idea of where that one goes. And I think you can tell I'm kind of going in order. Yeah, this is the next one, parentheses one's just kind of weird. Like you would say the quantity of. I know that seems really simple, weird, but that's what a parentheses would be because you're doing something in brackets, the quantity of. We'll stay away from the parenthesis ones. I'll probably only give you just the addition, subtraction, multiplication, division, equals ones. Okay. Okay, so now those ones were in order just to kind of get you rolling here. Now I'm going to start throwing them all over the place. Quotient. Quotient starts with a Q. Quotient. Total. Total. And not the cereal. We're just talking about total. Product. Product. Decrease. Okay. Let's try where we got here. Double. Right? The word double. Where would that go? Where are we here? Will be. W-I-L-L-B-E, like two separate words, will be. That's a tricky one, but I mean, if you put it in the form of a sentence, you can probably figure out, right? What would you say? Like 10 divided by 5 will be 2, right? The will be is your main part of it. Where are we? Added to. Try added to. Put that in the right category. Percent. Let's stop there for a sec. Where did you guys put percent?
Division.
Division, you said?
Yes.
Yeah, division.
Division. That's a tricky one. A lot of people would say, well, maybe that's multiplication, but you think about what our definition division, percent was, it means out of 100, right? So it's some number divided by 100, right? And what it is, I mean, I could go word after word after word after word, and you'd be like, well, where's everything going? So let's take a look back here. And I think I put, so that was the blank sheet. Here's the words and phrases and the symbols, right? So if you look at this, this is what I was reading off of, right? I was just reading off of all these different ones. And you can see how many different words there are for addition, for subtraction, for multiplication and division, right? So if you get students in your class and they are not English as a first language, they are going to struggle with math just based on the vocabulary. right? And you think about all the symbols we have, even for multiplication, right? We have brackets, we have a dot, we have a little X, we have an asterisk. We have different symbols to represent different things too. So this is why a lot of people have trouble with math, is there's just so much stuff all over the place. Okay, that'd be a great one if you're working with kids in your classroom. Use that, you know, give them what you could do is you could have.
Is it just me, or did you just go muted?
I think you're muted, Brian. We can't hear you.
Yeah, you're pretty quiet.
Your mic is on, but we can't hear you.
Your headset
I think
is done for today.
1
I think.
minute before class is done.
Hey. This is what they do.
We can hear you now for some reason.
No, just very slightly.
Okay, how about now? Is it clear?
Perfect.
Yes.
Okay. See, there's a good lesson. When you all become teachers and have to do remote learning, sometimes technology is not your friend. Always have a backup. Huh, weird. Okay, sorry. Yeah, if you're doing that with your classroom, have that in front of you. Like, you know, do poster board on the tables, one for addition, one for subtraction. And every day as they come in, give them the word plus. They put it on the right one. Give them word subtract and they put it on the right one. It's a great learning experience because if some kids don't know where the words go, sometimes they'll wait and watch where other kids put it down. And then they're actually learning something without being embarrassed, right? Kind of a neat idea. Okay, now, hopefully, if you had a chance, you printed off this 4-quadrant puzzle. If not, you can still do it. You just need a piece of graph paper and you're going to draw your line. So what you're going to do is you're going to draw on here. And if you notice, it says -3, 0, right? So you start at the origin. -3 means you go to the left and you don't go up or down. So you'd put a dot right there at -3, 0. And then the next one's -4, 1. So you go there and go -4, -1. Put the dot, and then you're going to connect those two dots from the -3, 0 to the -4, 1. Now you connect the dots in this whole first line until it says end of sequence, and then you don't connect those dots anymore. So in the first one, you're going to have 1, 2, 3, 4, 5, 6, 7, 8 dots, and then connect them. Then start the next sequence. You're going to do all those ones, connect them, and then end the sequence. And what this is, and you can get these are where this is from. I forget where this is from. You can go to the internet and get tons and tons of these. and they're really good on how to graph. Like if you're teaching people how to graph, Cartesian planes, X's and Y's, bang, put them on there. Okay, so take some time, graph that out, and let's see what we get. The shape of it. And then we'll find out at the end who got what. Because we don't want to give away the secret here. Okay. Just always start at the origin and then do your points. So -3, 0, first point. Then you go back to the origin and do -4, 1, -1, put your second point. Go back to the origin, -6, -2, put your point, right? Just keep doing that. Always go to the origin. I'm just taking my headset off on this. I can still hear you talk.
Should we connect the dots right away?
On the first line, so right, if you have your -3, 0, your -4, -1, that whole line there, you can connect all those dots, right?
Yeah.
And then do your next line and connect those dots, right? Every time it says ends of sequence, you stop connecting the dots and move on to the next one.
Brian,
Yes.
I have a question about the 8.2, the practice questions. Question 5, the
Hang on a sec.
distance.
Hang on a sec. 8.2, question 5. Compute the distance between these two pairs of points, okay?
I'm just gonna show you my screen because
That
I
works
want to
too.
know if I did it properly. I'll show you one answer.
Yeah, give me a sec here. I wonder if I can enlarge
Wait.
this. Or...
That's if it shows. If it shows properly.
Hang on. Don't move it. Don't move. Hang on. So x1, y1, x2, y2. So then you did 4 minus -2 plus 13 minus 5. And so then you did 6 squared. Yeah, that looks right. What's the answer say in the back? Or
Okay.
did it? Is that one of the ones that didn't give the answer?
Wait, I'll double check because I don't usually look at the answers in
Oh
the
no,
back.
no problem. Yeah, it looks right. Like math wise, it looks pretty clear.
Oh yeah, okay. That's the one with the answers. I got them both right.
Okay, good. kind of the whole thing behind this quadrant puzzle. And you can start with easier ones. There's easier ones and more complex ones. So if you're really trying to teach kids how to graph, like Cartesian points, right? It's repetition. You got to get it over and over and over and over again. So little activities like this actually kind of make it fun because you're still trying to draw a picture, right? And then you can have contests, like you can see who could do it the quickest, right? Come be fun to work in a pair. One person has to find the X value and the other person has to find the Y value, and then you put the point. So you have to do a little bit of teamwork there. That would be interesting in some of the classes.
Can I guess what it is?
Can you get rid of what, sorry?
Can I guess what the shape is?
Hang on, give me two more minutes just to get everybody to a chance to see what it looks like. Some of them, if I actually made you hold it up to the camera, would be friggin' hilarious. Some of them, because some people get lost like on one point and then they just, what the heck happened?
Yeah, that keeps happening to me. I was trying to figure it out, and then I kept forgetting where I was and what I had done, what I hadn't done, and I think it'd be better if I did this on my own time.
Yeah, you do it. Like, for instance, you would do, like, let's say you would do -3, 0, and then put a little line through it so you know that you've done that one, right? And then do -4, -1, and put a little line through it, like on the page, so then you don't lose track of where you are.
So
Oh, believe me, I've learned a lot of ways to keep organized.
So just to clarify that, Brian, the first value, like in the first row there, -3, 0, the first one is always X, correct?
Correct. It's alphabetical, X, Y. So you start at the origin, right? So if you look at my screen there, you start at the origin. The X is -3, so you go 1, 2, 3, and we go left because it's negative, right? And then the Y is 0, so you don't go up or down. So your first point should be right on that -3, 0, and you put your first dot. Then you go back to the origin, and we're going to do the second one, -4, -1. So we go 1, 2, 3, 4. There's our -4, and then we go down -1, and that's where you're going to put your second dot. Okay.
That makes a lot of sense now. Yeah.
And again, like I said, if you're teaching this to kids, you got to give them practice on this of how to do it X and Y, X and Y, X and Y, over and over and over again. Okay. Let me look back at the comments here. Eric, yes, Eric made a comment before of what it was. So if you feel bold, just so I can see them, turn your camera on. Justin's already doing it. Turn your camera on and hold it up to the camera so I can see what it looks like. Wow, Justin, not bad, Justin. That looks good. Nice. Anybody else? Come on. Oh, here come the cameras. Okay. Yeah, Alice, that looks pretty good. Olivia, come on, I can see you smiling. That's yours. By the way, it's supposed to look like a plane, and some of you will hold it up to the camera, and it'll probably look like a plane crash, if I'm not mistaken. Oh, Olivia's nodding. She goes, "Oh yeah, oh yeah." But again, it's one of these really good activities because it really shows you if you want a graphing. It gives them, and you can get tons of them. You can get simple ones like houses, right? You can get birds. You can get any sort of animals. Anyways, Well, thank you for sharing those that shared it. I didn't see any plane crashes. Nobody showed me a plane crash. I'm disappointed. Oh, Justin's fixing his. I can see that right now. He's trying to make it look like a crash. Oh, Heather.
Mine's like really bad. I think I messed up somewhere.
Okay, let's see, Heather. Yeah, looks like the wings came off the plane. But you got the general shape in there, so you were getting like the propeller in the main part of the body there, the fuselage, I guess it would be called. No, they're fun. I think they're fun activity.
They're pretty good. I have a pencil that erases pretty good.
Oh yeah.
I kind of have like a little my bottom of my plane went down there. Right?
Yeah, I see that. But then you got to fix it, right? So, and again, like even what Sam was saying, you're going to find students have that issue too. Like you're going along to the points, and you can easily get lost in the points, and then where do you go? You almost have to go right back to the beginning again, right?
Like for me, I didn't print this thing off, so I just had a piece of graphing paper.
Oh yeah. It's way harder that way. Yeah. Okay. Okay. Well, I mean, honestly, I have nothing more for you today, so we can finish. I mean, it's only 15 minutes early, but we can finish today. For those that want to stick around and have questions, like some of you are still finishing up like a couple of questions on the assignment, feel free to stick around, and I will answer those questions. And just remember, Monday is a holiday, so there's no class. So I will see you guys on Tuesday. And yep, I will see you on Tuesday. Please pay attention like to the stuff that's coming up, like assignment 4 when it's due, right? It's on the web page there. Here, let's take a look at what we got coming up here.
Math test on Wednesday.
Oh, do we have, okay. So the next assignment is due on the 27th, right there. And what'd you say, next Wednesday?
Yeah.
Wednesday. Oh, there it is there. And you can see exactly what chapters it's on, right? Chapter 7, 8, and 9. So we'll have class Monday, test Tuesday, class Thursday. There we go. And we are officially half done the course. Woohoo! 3 weeks have gone by. Okay. Let me stop recording here. And then for those that have questions on the assignment, you can stick around. And if not, the rest of you can have a wonderful weekend.
So we don't have class on Monday, correct?
Right. Monday's a holiday.
Okay.
Like if you look at right here, it says Victoria Day, no school. Right there.
Okay. Something else just came to mind. I was going to ask you, but I can't remember what it is. So maybe I'll
Oh,
just
no
email
problem.
you about it.
Take a minute and remember. Let me hang on. I stopped sharing this and let me stop recording here. Hang on a sec. There it is there.
Have a good weekend.
You too.